All right, so 7.1. Now we're going to deal with the last two types of properties for exponents. So let's look at what we've already done. Let's look at what we've already done. So we have the product property, which is when you are adding the exponents. The quotient property, when you are subtracting the exponents. The power property is when you are multiplying the exponents. The power product and the power quotient, both of these are distributing. Both of those are distributing the exponents. Now, I'm pretty sure a couple people are going to wonder, is there a property where you divide exponents? There is a property for dividing exponents. That's a property that goes with square roots, which most of you will be learning that in Algebra 2 trade, because that's when you see it the most. But don't be surprised that if you see it on a extra credit part of a quiz or a test, hint, hint, wink, wink, that it might be there. But dividing exponents are more so with square roots. So, those are the 5 that we've done. There are 2 other properties for the 2 types of numbers that we haven't touched yet. That would be 0 and negative exponents. Those are the only 2 numbers that we haven't really touched yet. So that's what we're going to focus on now. Now, the key thing to keep in mind, these properties are normally used near the end of the problem. These are properties that you use near the end of the problem. So, let's start with the 0 exponent property. So the 0 exponent property is very, very simple. Anything raised to the 0 power is equal to 1. Period. Whatever the 0 is attached to, it cancels out and becomes 1. Done. Whatever the 0 is attached to, that drops out and becomes 1. That's what that property means and represents. Now, most people mess up this property because they're being careless and not paying attention. So you have to pay attention to the problem. The only part that drops out is the part that has the 0 attached to it. So let's look at example number 1. Example 1, you have 12y to the 0 power. So you have 12 and y to the 0 power. So the 0 exponent is attached to the y. It's not attached to the 12. It's not attached to the 12. If it was attached to the 12, it would have been written as 12 to the 0 power. That's what it means to be attached. So the 0 is attached to the y. So the 12 comes down. Y to the 0 power is 1. And that's easy enough. 12 times 1 is 12. That's it. Problem's over. All to that problem. Any questions? Example 1. Yeah, this is 4th quarter. All of you all have been in this class long enough to know And closed mouths don't get fed. And if you have a question, you better speak up. Otherwise, I'm going to assume that you know what you're doing and all that stuff. You don't get to wait until a week before the quarter ends to then start asking, can I start teaching all this stuff? The answer to that is no. All right, example 2. A to the 4, A to the 3rd, B to the 0, C to the 5th. What part has the 0 attached to it? What has the 0 attached to it? The B does. Thank you, Alyssa. The B does. So B has the 0 attached. Not the -4, so that comes down. Not the A, so A to the 3rd comes down. B to the 0 does, so that changes to 1. And C to the 5th comes down. So again, the only part that changes to 1 is the part that had the exponent of 0. That's the only part that gets to change. Any questions before we continue? So now we got to clean this up. We can't leave the -4 and the 1 sitting there. We got to put those together. So there's no plus sign in there, there's no minus sign in there, and there's no division sign in there. So we need to multiply those two numbers. -4 times 1 is -4. Any questions 1 and 2? Yeah, if you have a question, don't be shy or scared, ask. And if you're afraid that someone else is going to say something, let them say something, they get to deal with me. They don't want these problems, they're not about that life. All right, example 3. So 9y to the -6 times 3y to the 6. So Shakaya probably remembers when I said that you can't have 2 of the same variable in the problem. We can't have 2 of the same variable in this problem. So what do I have to do with those exponents? This is one of the properties we did last week. We're multiplying with the same base. What do you do with those exponents? You add the exponents. So when you multiply, so you're multiplying with the same base, that's when you add the exponents. So 9 and 3 are not exponents. So we do 9 times 3, which is 27. Keep the y. Add the exponents. -6 plus 6 is 0. So now we got the 0 exponent. What is the 0 attached to, the y or the 27? The y. So y to the 0 becomes 1. And 27 times 1 is 27. 27 is your final answer. Questions, example 3. So let's do example 4. Move to negative exponents. So 63 b to the 8th divided by 7 b to the 8th. We can't have 2 of the same variable in the problem. So, what are we going to do? The exponents. What are we going to do with those 2 exponents? I'm not going to add them. What are we going to do with those exponents? I know what I'm going to do 63 and 7. 63 and 7 are going to get divided. That's 9. What are we going to do with the exponents? I'm going to subtract them. So that's the quotient property at work. If you're divided and you have the same base, you keep the base and you subtract the exponents. That's one of the other properties that we did last week. Again, if you're struggling with what we did last week, you got to come in and get extra help. I can't come to you, you got to come to me. 8 minus 8 is 0. What has the 0 exponent? The 9 or the b? What has the 0 exponent? 9 or the b? Which one has the 0 exponent? The 9 or the b? Not speaking a foreign language here. Which one has the exponent? 0 exponent, 0 attached to it. Don't be afraid to be wrong. What's the worst thing that can happen? Which one of these two has a 0 exponent attached to it? Oh, let me just wait for a second. Some of y'all gotta figure this out. One of those has 0 exponent attached to it. Hey, alright y'all, it's not that hard. If y'all were in class, it would be easier for me. I just call on someone and call it a day. And then when they don't respond, I can take points off their grade. I don't do that during remote because there are other factors going on. Again, if you don't know or if you don't understand something, speak up and say something. Otherwise, I can't help you. So b to the 0 turns to 1. 9 times 1 is 9. Again, some of you all, I'm confident that you know what you're doing. But there's some of you all, because you don't speak up, I can't trust that you know what you're doing because you don't speak up. Questions on the 0 property before we switch to the negative exponent property. All right, negative exponents. So the negative exponents is the trickiest of the 7 properties because this is when you do a lot of moving around. This is where you do a lot of moving around, and it depends on where the negative exponent is located. So negative exponents are not allowed, period. So up until today, they were okay because you didn't know that this property existed. However, if you have a negative exponent, so if you have a negative exponent without a fraction, you're going to make it a fraction, change it into a fraction, make the negative exponent a positive exponent. If it started out as a fraction, you flip it around, flip the fraction over, and make the negative exponent a positive exponent. Negative exponents are tricky because the only part that moves is the part that had the negative attached to it. That's the only part that moves. These are trickier. Meaning you have to pay attention to what you're doing because it is tricky. So we're going to start with some basic examples before we graduate to harder problems. So, let's start with a basic example. 9 to the negative 2 power. 9 to the negative 2 power. You have a negative exponent. So, since there is nothing in front of the 9, there's nothing in front of this 9. So you're going to rewrite it as 1 over, keep the 9, but instead of a negative 2, you're going to make it a positive 2. 1 over 9 squared. Again, since there's nothing in front, there's nothing in front of the 9, so you put a 1 on top of the fraction. Take the 9, rewrite it, take the negative 2, and make it a positive 2. Then you can solve it out. 9 to the second power is 81. So it's a rewrite problem. You write it first, and then solve it. Any questions? Example 5. All right, example 6. Again, let's do another basic problem. Another basic problem. 1 over h to the negative 3 power. 1 over h to the negative 3 power. So this time, the negative exponent is at the bottom of the fraction. So this is what happens when it's at the bottom of the fraction. Take the h and you move it up to the top. So that's 1h. Take the negative exponent and make it a positive exponent. So you're going to take the part and move it up to the top. So since you moved everything from the bottom of the fraction, there's nothing down there, so it's 1. 1 divided by 1 is 1. 1 to the third. So think of negative exponents as a fraction. A If you have a negative exponent at the top of a fraction, you move it to the bottom. If you have a negative exponent at the bottom of a fraction, you move it to the top. Either way it goes, the negative has to go. Any questions before we continue? Yeah, it's a trickier concept. So if you don't understand something, you have to ask. Oh, well, let me do as soon as you want to do it. And I'm going to find out on Friday when you have your first quiz in the fourth quarter. All right. So let's make it a little bit more difficult. So example 7. You have x to the third and y to the negative 4. X to the third and y to the negative 4. So which variable has the negative attached to it? Which variable has a negative exponent? You have two variables sitting there. Which one has a negative exponent? So that's y. Thank you, Alyssa. That's y. So that means the x doesn't have a negative exponent, so that means you will not be moving the x. So x to the third. So first we're going to rewrite this as a fraction. X to the third is not going to move. So x to the third stays where it is. The y is going to move to the bottom. Y moves to the bottom, and the negative exponent becomes the positive exponent. All of your exponents at the end of the day must be positive. All of your exponents must be positive. Any questions on example 7? We're going to move it right along. Those people who are struggling, they don't have to figure it out. All right, so example 8. What has a negative exponent? What are the negative exponents attached? What has a negative exponent on it? You have to identify it before you solve it. I see an m has one. So m is raised to the negative 3 power. And n is raised to the negative 7 power. You have two negative exponents. You got two of them. Okay. So you have a negative exponent at the top, and you have a negative exponent at the bottom. So the negative at the top is going to move to the bottom. The negative at the bottom is going to move to the top. The 4 didn't have anything attached to it. 4 is going to stay where it is. M moves to the bottom and moves to the top. So all you did was some moving around. You rearranged the furniture. Any questions? 5, 6, 7, or 8? You have to know what to do with a negative exponent before you can start solving it. Let's give about a good 45 seconds for those people who need to finish copying down any of those examples to do so before we move to example 9. Keep this train moving. About 15 more seconds. All right, keep the train moving. So example 9, negative 12v to the negative 8 times 4 to the negative v to the third power. So remember, you cannot have the same variable in the problem. So if I'm multiplying with the same variable, what do I do with the exponents? So what am I going to do with those two exponents? Something has to do with them. Add them, subtract them, multiply them, distribute them. Something has to happen. I know it's going to happen to negative 12 and 4. I'm going to multiply those together. We're going to the multiplication side of the problem. But what do I do with the exponents? And this is when it's beneficial to ask and to get the clarification. Because I can't tell you once you have the quiz in front of you. Once you have the quiz in front of you, on your own. You have negative 8 and 3. You're multiplying with the same base. You add the exponents. You add the exponents. So negative 48 v to the negative 5 power. So last week, this would have been okay to leave as your final answer. This week, you do this now, that's wrong. Because you have a negative exponent. You have a negative exponent. So now you make it a fraction. And the b has to move down. Negative 48 over v to the 5th power. Negative 48 over v to the 5th power. Any questions on example 9? All right, so finishing up with example 10, we have 2m squared raised to the 4th power over 8m raised to the negative 14th power. So, move this up a little bit just to give it a little bit more room. So, first thing you need to work with is the top part of this fraction. So the top part of the fraction, you have a parentheses. So that means you're going to be using your distributing properties. So remember, you have two different bases raised to the same exponent, you distribute that way. Or you have a fraction raised to the same exponent, and you distribute that way. Now, since we don't have a fraction inside the parentheses, we just have two different terms, we distribute using this first property. So at the top you have 2 to the fourth, and then m squared raised to the fourth. Bottom we leave alone. So we work out the top. 2 to the fourth power is 16. Now, if you look at the parentheses, you have one base with two exponents. So that means you use another property. If you have one base and two exponents, that's when you multiply those exponents. So x times y. So m, 2 times 4 gives you 8. So we have 16m to the 8th power over 8m to the negative 14th power. So that's all well and good. You still have to simplify that because you can't have two of the same variable. 16 divided by 8 takes care of itself. That's 2. And then you have 8 minus negative 14. 8 minus negative 14 gives you m to the 22nd power. So you finish up with 2m to the 22nd power. Since you edited with a positive exponent, there's nothing that you need to change. There's absolutely nothing that you would need to change there. So, with the 0 and negative exponent properties, do understand that you can still use any of the other 5 properties depending on if they show up in the problem. With that being said, that takes care of section 7.1. All 7 properties are now at your disposal. Use them as you need to use them. If you have any questions, ask. Otherwise, take care and have a good one.